All right, we're looking at full 3x3 linear systems this week. We got an intro last week. Here are the steps for solving 3x3 linear systems. The first thing you need to do is pick any pair of equations. We're going to be given three equations, three variables, hence the 3x3. We're going to pick any pair of equations from the system, eliminate any variable you want. Typically, there's going to be one that looks pretty easy to cancel out. You may need to eliminate one equation or both in order to get some variables to cancel. Second step, we're picking a different pair of equations, but we're eliminating the same variable as step one. Again, you may need to manipulate one equation or both in order to get them to cancel. Next, what we're going to be left with is a 2x2 system, which we've spent time with already. We're going to solve that system. We're going to take those two solutions we find and substitute them back into one of the original equations and solve for the third variable. Let's jump right into an example here. So we look at this 3x3 system. The first thing I like to do is I like to number them. All right, it organizes our work a little bit better. It helps me out to talk about it and all that. Now, I'm looking at the equations. The first thing I look for is, can any of the variables cancel out as is? I look, I see the y's are pretty well set up to cancel out. All right, they're all 5 y's. We got 1 positive, 2 negatives. That's what we need. So what I'm going to do is I'm going to add 2 equations together. I'm going to do 1 and 3 first. I'm going to add together 1 and 3. So 1, I'm going to rewrite them. You do what you want in that step. Sometimes we can just kind of look at it and see what we got. I'm also going to notice something else that's going to happen here. So I add straight down, and this is my result of adding together 1 and 3. X's cancel, which is nice. Y's cancel, which is great. That's our plan originally. The X's is just extra. We get negative 6z equals negative 18. You just go ahead and solve. Divide by negative 6, and z equals positive 3. So z is going to equal positive 3 here. That's one of our solutions. I need to find 2 more. Now, I don't have anything with just 2 variables. I lucked out and found z right away. I need to add together another pair. I need to do a second pair, so I need to do 2 and 3 this time. So I'm going to rewrite them. 2 and 3 is 4x minus 5y plus 4z equals 19. 3 is x plus 5y minus z equals negative 20. I add straight down. My original goal happens of canceling out the y's. I get 5x plus 3z equals negative 1. Now I have an equation with 2 variables. I already found z. Like I said, I got kind of lucky here. I'm going to take that z. I'm going to plug it into that equation there. So I get 5x plus 3 times 3 equals negative 1. 5x plus 9 equals negative 1. Subtract 9, I get negative 10. Divide by 5, I get negative 2. There's solution number 2. I have my z, I have my x. I go back to the top. I have 3 equations to choose from to figure out what my y is. I'm going to pick equation number 3 because it looks pretty simple. The y is positive 2. So I'm going to go ahead and plug that in. I'm going to plug in negative 2 for x. We're trying to find y. I'm going to plug in 3 for z and go from there. Take this in as many steps as you need. In my case, I'm going to just go ahead, combine like terms here. I have 5y minus 5 equals negative 20. Add 5. 5y equals negative 15. Y equals negative 3. I have 3 solutions. I'd prefer to have it written as an ordered triple, and which is -2, -3, and +3. And there's your solution.